Alrighty, everyone. So today we're going to be talking about a new proposed topic that we call device local diagnosis. My name is Greg. I'm a software engineer at Cisco.
Hi, I'm Shashank. I'm a software engineer at Google.
Yeah, and so let's just go ahead and dive right in. So today we're going to go over a couple things. We're going to, first off, take a quick little overview of what we see as sort of the issues in the space, move into our newly proposed topic, this device local diagnosis, provide some information about how this is going to be defined by vendors, moving into how it works on Sonic, and then finally how it works with the telemetry aspects by network operators. So first off, health monitoring on the switch is sort of very hit or miss. There are a lot of different processes that run on the switch that cover a lot of common things, but they are very limited in the specificity they have to individual vendors. They lack a remediation procedure. They're very inflexible when it comes into how they actually handle the signals that vendors are putting into these systems. Many times there's an over-reliance on parsing of logs when it comes to the operator side of things. And even then, when there are services, they don't cover all components. They only cover common things like, say, power supplies or temperature sensors, which are still critical, but they miss a lot of the sort of smaller things that can still be critical or specific to a vendor's operation of a switch.
All right, thank you, Greg. Taking over on the operator side, I think there are mainly three large challenges. One is lack of standardization. So here, the operator has to depend on like proprietary interfaces or logging to detect any faults that we see in the switches. The second is the maintenance operations are complex and irregular depending on the vendor or platform, leading to inefficiencies. And the third is, I think it's a high cost to integrate a new vendor or a new platform because the interfaces are not standard.
Yeah, so to address this, this idea of device local diagnosis is basically a generic framework that we have for vendors to define rules associated for monitoring and managing hardware failures and other failures on the device that is intended to be extremely flexible, standard, supporting multiple underlying versions of both hardware and software, and provides that sort of generic framework both on the input side for the vendors and the output side for operators. So sort of a quick idea is you have this input file, which vendors are going to define through the standard schema, which will be taken in by the process running on the switch. It will do monitoring that we'll get more into in a little bit. Any faults it detects and is unable to remediate, it will then push into the Redis tables, which will be sort of converted through into Openconfig for sort of subscription and monitoring by a remote controller through gNMI. Yeah, so why do we think this is a good idea to use? Basically, there are 6 high-level points, I think, that really sort of give the idea of why device local diagnosis is a good idea. So first off, as I've sort of said multiple times now, it is a vendor standardized framework. So there will be a common input and output regardless of the underlying NOS that we are allowing people to integrate with. Vendors have the most insight into how their hardware works and so are best at defining how to actually monitor and remediate failures on their own devices. You are able to sort of minimize a lag time by allowing for rapid failure response on the switch itself, sort of separate from a network operator having to monitor and manage potentially tens of thousands of devices in a network. You've standardized this aspect of the telemetry being pushed to the controller. You have that self-repair aspect, and it's really just at its core streamlining the experience for operators in their networks. Yeah, so now we're going to spend a little bit of time talking about the schema that we have defined for vendors to actually define these rules in their systems. So when I say a rule, what do I mean? A rule is a generic condition that a vendor can define that has a source of information, a logic for how to evaluate it, and information about how to remediate it. When it comes to the actual schema, each rule is comprised really of 3 primary blocks: metadata information that provides contextual information and sort of high-level context to how the rule is actually taking effect. a conditions block that explains the individual events that a vendor can define for how this actually is going to be monitored and evaluated, and an actions block that explains how both the local switch can attempt to remediate, or if that is unsuccessful, the remote operator can remediate and address these failures on a device. Sorry, one thing I forgot to say. As part of this conditions block, to try and sort of remove and complexity from the vendor rule onto the switch, onto the sort of NOS side itself, we're defining an additional sort of component called the data source extension, which is basically just a way for vendors to provide very high-level definitions of a rule input or an action that are then converted and better mapped and understood on the switch itself. So yeah, as I sort of mentioned, data source extensions are this ability to abstract away this complexity from the source of these rules into a separate file that the vendor would maintain that is more sort of on switch, on hardware specific, that allows for a rule to have a definition that varies potentially. So a good example of this would be, say you have a rule that has data that's available only via like a direct I2C read to the device in some 2024-05 version of Sonic. Then that rule, that content is now stored somewhere through a platform API that you're able to directly access. You can use a DSC to sort of abstract away that complexity and manage that on the switch itself, so you don't have to support multiple different rules across multiple different software versions and sort of make it much simpler for you to maintain as a vendor. Getting a little bit into the idea of the logging that you can define for in this actions block. You have two different discrete ideas. One is a per fault, where you're collecting logs on every instance of a failure. And then the other is you have a much larger set of logs that you're collecting on the network operators on demand to provide a lot of like very specific contextual information related to a fault. And all this information will be included within the rules file itself of what to collect. So we're going to kind of speed through this part because I just wanted to give some information about how these rules are actually structured within the device. This slide is now a little bit out of date. The sort of schema is changing rapidly as we sort of go through this development process. But at its core, I just wanted to walk through a couple of the fields. Something like a software version or a component, like parts of this are vendor defined, right? We've defined fields that need to be populated, but how they are actually interpreted and read on the switch are determined and implemented by the vendors themselves. You have product IDs also that fall into that bucket where it's something very like vendor specific. In my case, Cisco, we may have a specific PID that we have defined or a specific hardware version, but we allow for that adaptability and integration within on the vendor's side to try and make it easier for vendors to sort of apply that aspect. Then within the conditions block, here's sort of an example of what a condition would look like. In this case, it is a rule related to some failure on a power supply where we defined a specific logic associated for the events to be interpreted with, this type that I'd referenced before, this DSE, where we're essentially like referencing an API in the device through a map that the device determines which it's going to call, and a way for us to evaluate that logically within the switch. I forgot these would show up like that. Another example is you have a very high amount of flexibility in how you want to define rules. So if you don't want to use this data source extension that I've mentioned, you have the ability to define things and embed them directly within the rules source. So in this case, we have some example of how we would parse the exact same rule directly via that I2C definition that I had hinted at earlier, where at a high level, it is the exact same, but we're allowing for vendors to have that ability to directly embed if they want to. And still parts of this are sort of vendor defined, right? Like we have this idea of a bus where it may be adaptive on the device and vendors have a way to identify that. In this case, we allow for vendors to sort of have their own implementation of how they're going to consume this information, as well as a base implementation where if they just want to define a number, we understand that. And now getting into the actions block. So for each rule, we have content related to the actions that both the local switch can take under the local actions block, and then the switch is recommending for a remote operator to take under the remote actions block. This is comprised of Openconfig-gNMIs for the remote aspect to sort of make this more generic across the scope and allow for vendors to determine how they want, or operators to determine how they want to run these. Yeah. So now we're going to move on a little bit to sort of how this works actually on Sonic, how the service on the switch is intended to be defined. So at its core, this proposal is involving a new service running directly on the switch, on the host itself, called the device local diagnosis daemon. At its core, it is comprised of 4 different threads, one related to how you orchestrate and act upon faults, and then 3 different threads related to how you can monitor these faults on the system. We've sort of split them up into sort of 3 groups, that being Redis file and everything else, where you have different ways of querying the information, and so rules will be batched into different threads for concurrent monitoring based on their type. Here's a high-level idea of how the proposed daemon will be integrated into Sonic. So as I sort of have mentioned earlier, right, you have this vendor rules input, which is what we sort of were going over before. That will be consumed by this service on the switch and ingested by this primary orchestration thread, which will batch the rules into these different threads and push them to these threads and spawn the threads for them to run. These threads will then, on their own accord, query the information and run the evaluation that has been defined within the rule source file and push any faults that are detected into this FIFO buffer between themselves and the primary orchestration thread. The primary thread would then sort of consume this information, take any local actions that are defined to try and remediate the fault, and if that fails, it would recheck and push the information into the Redis tables for that fault telemetry to be published. We also are doing all of the log collection that I had mentioned earlier through GNOI health Z. So we leverage the artifact component of that health Z RPC to collect, manage, and store those logs for a remote operator to collect at their own accord. So I've talked a lot about actions. What are these actions? How do they work? As I sort of mentioned earlier, there are 2 blocks of action types. One would be local, so these are things that are run on the switch on every instance of a fault to attempt to remediate and recover it. These are sort of defined in such a way that they have to be non-disruptive. The switch is not allowed to, on its own accord, take actions that would interrupt, say, the data plane of the switch. We don't want a system to randomly go down for some random fault on a system if it is still capable of passing traffic. Anything that is going to actually impact the state of the network, we want to leave that to the operators to handle. So that would fall under this remote actions bucket. This is a sort of block of suggested escalating actions that for the operator to consume and act upon at their own accord. They can also fall into this idea of non-disruptive versus disruptive. But even then, at its core, the operator is what determines how these are run, when they are run, and if they are able to run. The log collection, once again, as I mentioned earlier, still split between per fault and on demand, but all of that is handled through artifacts in this health Z GNOI RPC. And this triggered on demand is larger in scope. It is not per rule defined. It is allowing the system to collect a much more deep diagnostic view of faults on the system for later sort of root cause analysis by either operators or the vendors. And so now I sort of want to walk us through a full example of how this would work on a system. So going sort of as this comes in, we have the rule that is pushed by the primary thread into this common monitor thread, because we're just going to talk about that DSE/ITC rule that I had sort of given as an example previously. That information will be collected and sourced by the thread on the DLDD process and compared against. When that sort of fault is identified, it's pushed into this thread-safe buffer. The primary thread will consume it and then perform a local action. In this case, say we would reset some output power rail on the switch to sort of attempt to correct and reset this PSU to get it back into an operational state. If that doesn't work, it then will push the information into Redis and generate this log telemetry via the health Z, and would be later consumed by this Openconfig-gNMI stuff, which Shashank is about to talk about.
All right, so the last section I'll talk about, by the way, thank you, Greg, for walking us through the PSU example. So far, we've seen the device diagnose itself, try and repair itself, but sometimes we need the controller to take action. So how do we get the switch to export this? Openconfig is the standard that you are going with. So today, the Openconfig component model already has a health Z subtree, which sort of generally specifies the health of or used to export the health of a component. What we want to do is add a list of faults under this subtree so that the device can export one or more faults for each component that the device contains. Now, these faults are defined by or identified by predefined symptoms. I'll talk about the details in subsequent slides. The faults also contain the list of actions, like Greg talked about, that the device is suggesting or recommending. And finally, there is the health-z-gNMI API that can be used to either retrieve the logs that were already generated, or it can also demand that new kinds of logs be generated that can then be retrieved over this API. All right, so faults. You can see here that there is an existing health-z subtree under the component model. Currently, it exports the state of the component of a device and general data around how many times it's been unhealthy and when it was last unhealthy and so on. So the leaves that you see in green are the ones that we are adding. So it's a list of faults. The key to this list is symptom, which means that there can only be one fault of each symptom for this component. On the right, you can see common symptoms that we've currently defined. This is by no means an exhaustive list. You can always extend this list. You can also have private vendor extensions. And then we also have two leaves that exports like two timestamps. One timestamp is the time at which the fault first occurred, meaning that the underlying condition was met for the first time. And the other one is the last detection time. So if the fault keeps occurring and if the underlying conditions keeps flipping back and forth, then this tells you when the last time the underlying condition was true. For a fault that's currently active, this would be the last time that it was polled. And similarly, some metadata around how many times this underlying condition was true, as well as whether it's currently true. Using the same PSU example, you can see here that for the component whose name is PSU1, it's right now unhealthy with one fault, which is over threshold. That is, the output voltage is over the recommended threshold. You can see that's currently active, and the underlying condition was met once. As part of this list of faults, the device can also export suggested actions that the operator can take to remediate this fault. This is a list, and it's typically in the order of least disruptive to most disruptive. Each action is predefined. You can see an example list on the right. Again, just like symptom, this is an extensible list. And also, the target of this action need not be the same component that has this fault. I'll use an example to illustrate this. Again, using the same example, you can see here that for the PSU overvoltage fault, there are two recommended actions. The first one is to reseed the component itself, and the target of this would be the PSU itself. And the second action would be to power cycle the chassis. And you can see that the target of this action is not the PSU component, but the chassis. All right, that sort of concludes our presentation. Thank you for your attention. I would like all of you, or invite all of you to contribute to this. So I've left some links here. We have the Sonic meeting calendar and mailing list here. The HLD for the on-device daemon and the vendor rules that Greg has authored, as well as the OpenConfig faults that we've authored, and links to some other READMEs and HLDs. Thank you.
Awesome, thank you. Any questions for the speakers?
Hey guys, that was a nice presentation. So wondering, did you guys ever thought about integrating with this Sonic system health checker, which already does some level of health status, etc.?
Yeah, so we decided to make this an independent service to focus specifically on vendor-defined faults, where it is very extensible through its own framework, where it's not Sonic specific at its core, both on the inputs and the outputs. Those are standard outside of just Sonic. As I'd sort of mentioned before, and you brought up, there are existing health monitoring services like HealthD on the Sonic switch, like PSUD, Thermal Control D, whatever, right? But at their core, they are generally pretty simplistic in that they have a defined common set of rules. And in the case of HealthD, it does allow for some extensibility for vendors to provide additional like scripts and management to extend that. But then you run into the issue where it's still not standardized on the output or the input of how that information is read, both on the switch, pushed out to the switch, and how vendors provide that information on the switch. So the high-level goal here is to give that generic standard framework where the only thing that is Sonic-specific is the actual process running on the switch, but everything else, input and output, from the switch to the switch, whatever, is fully generic.
Great, thank you.
Yeah.
So it seems like there's a lot of capability here for the vendor to kind of normalize and provide a vendor-specific view of what the health and correctability of the system is. I'm wondering, is there any kind of notion of configurability of that for the operator? So the operator might have different requirements in different places where they might use it.
Yeah, so we get into more detail on that specific part within the HLD, so I would recommend that you take a look at these HLDs that are linked here for some more information. But to answer your question specifically, there are several aspects of the service that are configurable by a vendor. So vendors have the capability of modifying the rules source file and updating that on the switch through GNOI. They can push a new version of this file that is the source of all these rules onto the switch and allow for that to be updated. Secondarily, when it comes to the remote actions, that's fully owned and operated by the operators themselves. So they have the capability of determining what is best for the operation of their own networks. And then similarly, there is configurability within the service about how things are monitored. So there's configurable polling intervals, there's configurable failure monitoring. Basically, the goal is to try and make it so that operators have this flexibility to integrate this into their networks as they want to. Yeah, I would suggest, though, if possible, that you take a look at the HLD, and there is some more information on that, but I hope that answered your question.
Yeah, thank you so much.
Yeah.
It was a great presentation. Thank you so much. So I have a little bit of confusion on the open config side, and you said the vendor-specific enhancements as well, right? So does the vendor-specific enhancement need to be like natively developed in their native schema, or against the open config, or what is it like?
So in general, OpenConfig is a standard set of models, right?
Correct.
Like
Yes.
you can have a vendor implement them, you can have an operator use them.
Right.
But along with that, within the device or within the switch software, you can also have additional models or extensions to the existing model that you can export. Now, typically, if we feel that some extension is beneficial to the industry, I would suggest that you just make that change to the public model under OpenConfig. But if there is something that is specific to a vendor or an operator, then yes, this allows you to have custom extensions that maybe is pre-agreed between one vendor and one operator.
Okay, but you guys are trying to say that whenever it's native config model, then please follow the same schema or the same design which you guys are put together, the same framework, sorry, you guys have put together.
So are you talking about the input of the vendor-defined faults or the output of how operators consume them?
Both the structures, right? So you have a remediation action one, and you have an input file, right? So that standardization is what you guys are
Yes.
trying to
Yeah,
put
so-
together, whether it's OpenConfig YAML file, or whether it's the
Yeah.
schema, not the YAML file, whatever it is.
Yeah, so for those input files, right, it's not Openconfig. It's following this standard YAML schema definition that we're proposing. To some extent, it is still vendor extensible, that there are fields where we've defined there is a requirement that there is a field here that populates some information, but how that is consumed and the format it takes is dependent on how the vendor wants to actually use it. And similarly, like extensibility from the event definitions comes from that data source extension we were talking about, that DSE type, where you have the capability of having a vendor definition on the switch that maps this string essentially into an API or some capability of querying the information. So that's sort of how it falls on the rule side. So there is still a standard schema. It's just extensible in how it's consumed. But then for the Openconfig side,
Yeah, I was going to ask, did you mean Sonic Yang schema versus the Openconfig-Yang schema?
Yes, yeah.
Okay.
Yeah.
So since this is Openconfig-Yang schema, you would have to extend the Openconfig-Yang schema
To the Sonic,
on the device.
Got it.
And have the operator also expect that.
Understood. Okay.
Yeah.
Okay. And on the action side, right? So you guys are planning to have a cadence on how to update that regular cadence, or how to update that the remediation steps inside that Openconfig schema.
so for the Openconfig schema, like how it's reporting these
Right.
requested actions,
Yeah.
You mean adding new kinds of actions?
Yeah.
So today the PR that you see defines the list of actions that are on the slide.
Correct.
If you feel that there are more, I'm sure there are definitely more actions we can add. The same thing that we talked about, like symptoms and both action types, you can extend the public model, or you can have local extensions that is specific to a vendor, specific to a platform. But it's just that the operator and the vendor have to pre-agree on what those are.
Understood. Okay. But you guys are not trying to have to build that
So
traction in the
our goal is not
community,
to
right?
build it for all possible vendors or all possible operators. I think we want to define the framework. We want to provide an example, let's say.
there's a base set that is included within the Openconfig PR of different symptoms and actions. So there will be a common definition that's part of the Openconfig model. And sort of as Shashank was saying, it's up to, like, if you want additions to that are specific to you, you would agree both between the operator and the vendor of what those are going to be, so the operator is able to understand and sort of process them. But if you have additional faults or like symptoms or actions, whatever, that you think are worthwhile to the wider community, you would extend and sort of push to the Openconfig upstream fault sort of table that has all of this information for other people to adopt.
Okay. So the takeaway I see is is the framework, trying to standardize the framework, how we can build this health diagnosis,
Yes.
across the Openconfig framework, right?
Yeah, and we would welcome your thoughts or suggestions on
Yeah.
if the framework doesn't work for you.
Right.
I think this would be the perfect
for
venue
sure,
to.
Yeah.
I'd like to very much encourage people to go and
Yeah.
leave comments on the design.
Thank you. Thank you so much.
Yeah.
Yeah. Bye.
Awesome. All right, now we'll take a quick lunch break and let's reconvene back here at 12:30.